Good morning students. I am your Nagini ma'am. Today I am going to discuss about how to remember examples of ideal and non-ideal solutions. Okay, this topic is from solutions lesson students. Okay, in the last section I discussed differences between the ideal and non-ideal solution students. Okay, so today in today's section I'm going to discuss about the how to remember easily examples of ideal and non-ideal solutions. Okay students, so we know that ideal solutions, non-ideal solutions. What is the definition students? Ideal solutions means the solutions which obeys the Raoult's law called ideal solutions, which does not obeys the Raoult's law are called non-ideal solutions. Yes, so in the here in non-ideal solutions, positive deviation, negative deviation from the Raoult's law. Two types are there students. Okay, so here how to remember easily example students. So because this topic is very important for the competitive exam students, here in the ideal solutions these so many examples are there. In the positive deviation so many are there. In the negative deviation so many examples are there, correct? So how to remember this all examples? We have to remember this, we have to by heart this all examples. No need students, just I will give the very shortcut. Okay now, so you can easily remember the examples of ideal and non-ideal solutions students. I will give the shortcut students how to remember the examples of ideal and non-ideal solutions. Okay students, now first I'm going to discuss about the ideal solutions examples. Okay, in ideal solutions example students, here once you observe this all example students, benzene plus toluene, n-hexane plus n-heptane, this all examples before only I wrote students because to save the time, to save your time students. Okay, try to understand. So here benzene, toluene, n-hexane, n-heptane, chlorobenzene, bromobenzene, ethyl bromide, ethyl iodide, n-butyl chloride, n-butyl bromide. Okay, now these are the examples of ideal solution. This all you have to by heart. No need students, easily you can easily identify the examples of ideal and non-ideal solutions. See students, here in the ideal solution students, here we can observe the same kind of the words, or we can say that prefix, the suffix or prefix is same kind of words will be there. So in two solutions, if you observe benzene and toluene students, here ene is there, correct? Here ene, so this is, see students, ene. Here also ene is there, correct? So same kind of words are there, so that's why we can say that this solution belongs to ideal solution. This solution is showing the ideal solution behavior. And coming to the second example, see students, n-hexane, n-heptane. So here what is the suffix students? Here this is eno, eno, correct? So this is the, it is the same, or n also we can take same, correct? So same kind of words are there, we can say easily ideal solutions. In the third example students, here eno, eno, correct? En is there, so same kind of words are there, so that's why we'll call it as ideal solutions. See here ethyl bromide, ethyl iodide, which is the same, ethyl, ethyl. So this is the prefix students, ethyl, ethyl, correct? Same then same kind of word is there, so that's why we'll call it as ideal solutions. In the last example, see students, n-butyl chloride, n-butyl bromide. N-butyl is the common, correct? In two solutions, n-butyl word, it is the same word, correct? So that's why we can say that these are the examples of ideal solutions. You can easily identify students in ideal solutions examples, Rana, only same kind of words will be there. Okay na, identical words are there in two solutions, so that is the example of ideal solutions. Clear this one? Now coming to the positive deviation. Okay, now here what will be there students? What is the shortcut students? Here identical words will be there. Clear this one? Identical words. Okay, see here I am writing identical words. So in the ideal solutions, what is the shortcut students? Ideal shortcut, same kind of words will be present. Clear this one? So same kind of words are present. Clear this one? So then we'll call it as ideal solutions. So now coming to the positive deviation from the Raoult's law students, here in these examples, so which solutions are mainly showing the positive deviation from the Raoult's law? So that means mostly nana alcohol, CS2, CCl4. You remember three only, alcohol, so CS2 CCl4. See students, here alcohol, here this is alcohol, correct? Vol is there, this is the functional group vol. Okay, and here CS2, correct? CS2 is there. Okay, and here vol is there. Vol means alcohol, CS2 alcohol, vol. Okay, now here CCl4, and here also CCl4. This is the special case students, this is exception, you have to remember students. And this is also CCl4. Okay, now and here alcohol is there. Clear this one. So in these solutions, Nana, in the mixture of solutions, any alcohol group is there or CS2 CCl4 there, we can easily identify those are the positive deviation from the Raoult's law students. So which are the examples of positive deviation students? Mostly which are showing alcohols, CS2 CCl4. Okay, and alcohol's functional group is function. What is the functional group? OH kada. We'll call it as what is the suffix? Vol. Okay, na. So alcohol CS2, carbon disulfide, vol, CCl4. This is the exceptional case students. This is the exceptional case. Seventh example. Okay, now this you have to remember students, this is exceptional case. Remaining all are we can easily identify by seeing the examples. Clear this one. Now coming which are showing mostly students alcohols, which are showing mostly alcohols, CS2 CCl4. Clear. So mostly shows which are showing alcohol, CS2 CCl4. Clear this one. See this three only remember students. Alcohols means what is the functional group students? OH kada, will call it as vol. Okay, na vol. So in compounds vol is there, that is alcohol. So that is the example of positive deviation from the Raoult's law. CS2 carbon disulfide, CCl4. In three examples, any one example will be there students. So then we can easily identify that is a positive deviation from the Raoult's law. Now coming to the negative deviation from the Raoult's law students, in these examples, once you observe, Nana, acetone, aniline, acetone, chloroform, methanol, acetic acid, nitric acid, water, HCl, water, acetic acid, pyridine, CHCl3, C6H6. So in these examples, students, how to identify negative deviation? You remember students, mostly acids shows the negative deviation from the Raoult's law. So which are showing students here negative deviation? Mostly acids are showing the negative deviation students. Clear this one. Mostly here I am writing. So mostly acids. Clear. Acids shows negative deviation. Clear this one. Negative deviation. Acids, mainly acids students. Clear this one. So mostly acids are showing the negative deviation. Here mostly alcohol, CS2 CCl4 showing the positive deviation. Here mostly acids. Where students here acids, in this example no acid. Here example also no acid. Okay, now see here. So these two are exceptional cases students. These two examples you have to practice. Ardhaita, you have to remember. And coming to next example, see students, here methanol acetic acid is there. Acetic acid is there. Okay, na. Then first preference should give to the only acid students. Here alcoholic functional group is there and COOH. Acids, this is acetic acid, this is alcohol. Madam, here OH is there now, then it is a positive deviation. No students. Once you observe the properly, if suppose alcoholic group, acid group both are there, first priority give to the acid only. Okay, namma. So acids will be there. So this is acid. Here acid is there, and next here nitric acid, HCl, acetic acid. Okay, na. And this last example also it is exception students. This example also you have to practice. Chloroform plus benzene. Clear this one. So these three examples you have to by heart students. In this positive deviation, this example you have to by heart. Remaining all you can easily identify by seeing the example. Just what you have to remember students, ideal solutions mostly which are showing students same kind of words were present in these solutions. So that solution, that mixture is showing the ideal solution students. Here eno, that is ideal. Here eno, ethyl, butyl, same kind of words or identical identical words are there in two mixtures, Nana, we can say easily those are ideal solutions examples. Positive deviation from the Raoult's law. How to tell students here positive deviation from the Raoult's law examples, mostly which are showing alcohol, so CS2 CCl4. So which are showing mostly alcohol CS2 CCl4. Alcohol functional group OH kada. So what is the suffix vol? So in the compounds vol is there or OH group, alcohol group is there, then those are the those examples are showing positive deviation from the Raoult's law. Okay, now see here vol CS2, here vol CCl4 also showing, CCl4 also showing. Yes, CCl4, this is exceptional case, and here also vol is there. Clear this one. So this is about the positive deviation. Negative deviation mostly which are showing students, acid shows negative deviation from the Raoult's law. Okay, the acids maximum showing the negative deviation. Here these two are exceptional cases, and this one last seventh also exceptional case. These three you have to by heart students examples, and these examples here acid is there. So that's why they are showing the negative deviation from the Raoult's law. Clear this one. So from this topic, how the questions will be there, how they in previous years, how the questions, how we got the questions. Once we will check it, students, in the previous year questions. See here, first question, students. What is the first question, Nana? Which of the following liquid pairs shows a positive deviation from Raoult's law? Which of the following liquid pairs? Which of the following liquid pairs shows a positive deviation from the Raoult's law? So positive deviation is asking question, which is asking positive deviation is asking. So positive deviation which are showing, students, actually positive deviation shown by mostly alcohols. Okay, CS2 CCl4. So in these three compounds, any compound is there, alcohol CS2 CCl4, then that is the example of positive deviation from the Raoult's law. Once we will check, students, here benzenomethanol is there. Okay, now benzenomethanol. So that's why here what is there, students? Alcoholic functional group is there, correct? Whole. So alcoholic functional group is there now. So that's why it is the example of positive deviation from the Raoult's law. Now see here, water plus nitric acid. This is acid kada. This is acid. Acid means which shows it is showing which deviation, students? Negative deviation. Correct? Maximum. I told you already. Negative acids maximum shows negative deviation. Clear this one. This is negative deviation. And come to here, water plus HCl. Here also acid is there. So this is also negative deviation. Clear this one. So this is also showing negative deviation. Acetone plus chloroform. Acetone plus chloroform. This is the exceptional case. This is also in negative deviation. Correct? Negative deviation. This example also I discussed you. This is the exceptional case. You have to by heart that one. See here, acetone plus chloroform. Acetone plus chloroform. You have to by heart this example, students. Okay, now acetone plus chloroform here also given. Understood, Amma? So which are showing positive deviation? These three are negative deviation. This is the positive deviation. Clear this one. So that is the answer is positive deviation. Option A is the correct one. Okay. Now coming to the second question, students, the mixture which shows positive deviation from Raoult's law. Positive deviation is asking. So positive deviation means mostly which are showing, students? Positive deviation which are showing mostly alcohols CS2 CCl4. Correct? Alcohols CS2 CCl4. See here ethanol acetone. So here alcoholic functional group is there kada. So this is the alcoholic functional group. Vol is there, and next here benzeno toluene. Okay, now this is benzene plus toluene. Okay, and acetone chloroform, chloroethane, bromoethane. See, students, it is see example acetone plus chloroform. Acetone chloroform, which one, students? It is the, you have to remember this example. This is the negative deviation. Correct? You have to by heart this example. This is negative deviation. Chloroethane, bromoethane, chloroethane, so these two are this example is ideal solution, students. This is the example of ideal solution. Clear this one. Okay, now, and this one, students, benzeno toluene. So this is also belongs to ideal solution, students. Okay, na, ideal solution. Benzeno toluene. Okay, na. Yin is there na. Toluene benzene. Understood? So that's why this is also belongs to ideal solution. Here in ideal solution, this is acetone chloroform. This is the exceptional case, you have to practice negative deviation. And coming to the ethanol plus acetone, here alcoholic functional group is there, so that's why it is a it is belongs to a positive deviation from the Raoult's law. So answer is which one, students? Ethanol plus acetone. Clear this one, ethanol plus acetone. Okay. Now third example, see students, what is the third example? All form ideal solutions except. Okay, here ideal solutions, for example, here four options given. All form ideal solutions except which is not showing ideal solution, asking. This is benzeno, this is methyl benzeno, so it is an ideal solution, correct na? Here this is benzeno, this is methyl benzeno, in is there, correct? It is benzene kada, benzeno. Okay, this is benzeno, this is methyl benzeno. So that's why here identical words are there, correct? This is the identical word, in. Okay, here also in is there, identical word, eno. So that's it is ideal solution. Now this one, this example is sorry, this is C6H6, students, benzene plus this is iodobenzeno. What is the example, students? Benzeno plus iodobenzene. Iodobenzene. What is the common word, students? Eno, we can take. So that's why it is also ideal solution. And coming to chlorobenzene, bromobenzene. So this is also this is also ideal solution, correct? Chlorobenzene plus bromobenzene. So here also identical words are there. So that's why it is also ideal solution. Now see students, this is iodobenzene, this is sorry, this is iodoethane, correct? Iodoethane, this is ethanol. Okay, now C2H5OH. Clear this one. This is iodoethane, C2H5 only. Okay, correct? C2H5I plus C2H5OH. Okay, now C2H5OH. C2H5I means iodoethane. Okay, iodoethane plus this is ethanol. Okay, so here what is the functional group, students? Vol is there, alcoholic functional group. Remaining all are ideal solutions, but this is alcoholic functional group is there, so that's why it is showing the positive deviation from the Raoult's law. Clear this one? See students, here examples once we will check. See, all form ideal solutions except this question, students. All form ideal solutions except this is benzene, this is methyl benzene, this is ethane, this is ethane, this is iodoethane. Okay, this is iodoethane. Okay, right, iodoethane, sorry, this is iodoethane amma. C2H5 kada, iodoethane. This one is what given example, I wrote wrong, C2H6 only given, sorry. This example is C2H6. That means C2H6 is ethane. This is the ethane plus this is iodoethane. Now see here also same N group only is there. See here students, benzeno, this is methyl benzene, this is ethane, iodoethane, this is chlorobenzene, bromobenzene, iodoethane, alcohol, ethyl alcohol or ethanol. See students, in these four examples here OH is the OH group is there, alcoholic functional group, so that's why it is belongs to positive deviation from the Raoult's law. So we know that positive deviation which are showing mostly alcohol, CS2, CCl4, correct? Alcohols, okay, alcohols, CS2, CCl4. So mostly they are showing the positive deviation from the Raoult's law. And one more bit to see students here, 17th bit. Okay, here which is the option, students? This one is correct. Now 17th option, 17th question, the mixture which shows positive deviation from the Raoult's law. Ethanol plus acetone, this is benzene plus toluene, acetone plus chloroform, chloroethane plus bromoethane. Now which is the example, students? Positive deviation which are showing alcohol is their whole functional group. Here eno, that's why it is ideal solution. This is acetone chloroform, negative deviation. Here chloroethane, bromoethane, eno, that's why it is ideal solution. So which is the correct option? Option A is the correct answer. Clear this, students, this topic. So finally what we can say, students, ideal solutions mostly which are showing same kind of words, identical words are there in two examples. Okay now, so then we can say that ideal solutions. Okay now, positive deviation mostly which are showing alcohols, CS2 CCl4. Clear this one. See here students, I am writing finally ideal solutions. Ideal solutions. What is the clue students? In the ideal solution, same kind of words are present. Correct? Identical words will be there. Identical words are present. Okay. Next, negative positive deviation. Positive deviation. In positive deviation, only alcohols, CS2 CCl4. Okay na, alcohol CS2 CCl4. So these compounds are showing the positive deviation. Now coming to the negative deviation, so which are showing the negative deviation students? Negative deviation, which examples are showing? Only mostly acids are showing, mostly acids. Okay na, mostly acids shows negative deviation. Clear this one. Positive deviation mostly shows alcohol CS2 CCl4. Okay na, here identical words are present. Okay students. Okay, thank you very much students. If you like this video, please like, share, comment and subscribe my channel students. Thank you very much students.